person using it to experience seriously mental illnesses. So thank you for your attention, and maybe you have some question to me, please, if I can answer.
Please, colleagues, your questions. I've got one question. What information?
Look,
yeah. What information technology or program tools have you applied to create a chatbot?
You mean? Do you mean like? I'm sorry.
The platform or a software?
I see. Look, we are psychologists, so our task was provide psychological technique. And we prepared our students, these voluntaries who get this help for this person who needs this help. Look, by the way, I can, for example, share my screen, and you can see how it look this application. If you, of course.
Yeah, we will be glad to see it, but unfortunately, we've got the time limit.
Okay.
Yeah. We know that you've got your chatbot, and you used in HPE as well. We have heard about this. Yeah,
but it's collaboration to other scientists from other department who did this application, like engineer.
Yeah, I understand. Thank you. Thank you for your presentation. So the next presentation is the influence of educational competencies of the staff on the efficiency of hotel companies in the tourism sector. Who will be the speaker? Please. So nobody at the moment here, so we will return to this presentation later. Let's go on, and the next presentation is method of multipurpose text analysis based on a combination of knowledge bases for intelligent chatbot. Please, Dmytro, Kudriavtsev. Yeah, and please turn on your microphone.
Do you hear me now?
Yeah.
Okay, so let's start. I want to present our article, Methods Multiproposed Text Analysis based on a combination of knowledge bases for intelligent chatbot. So the main goals of text message recognition for chatbot is adequate level of text recognition. It's understanding what the user wants to say to us, and in this case we need to investigate what we need to show to the user, the results, or maybe some additional information. Also, it's a self-study based on previously received information that's improved us in the next sessions for users to give more important information to it, and also its ability to introduce the analysis of using user data, like to improve in the next sessions, as I said before. So the relevance of this article is that we can use it in mobile applications to detection and screening spam messages, also to improve user experience on websites or in help services. The main text recognition issues that we found is that semantic analysis can create some anomalous situations related to short form of words that user entered. Also, it's bad data like syntax errors in user speech, and also the main issue is that the data for analysis needs to be divisible, because when we select the topic when we want to present to the user, we need to create a database of information that we already understand. So in this case, this data will be so big, and we need to to split into several databases. So the solutions which are provided to resolve this is using filter based on frequency for avoiding nonsense text constructions. That means that we need to avoid some words like and, or, and something else. Why not? Yes, also we need to use integral memory for checking user data when the user entered some copy information, for example, hello, and then he entered one more time hello. We need to avoid this because it takes some time for analysis, and this can help us to improve the performance. Also, we need to separate analysis of each terminology database. It helps us to improve time performance also, and all of our terminology database will be worked in parallel. So in this case, we can use several terminology database without time consumptions. So also, in some cases, user entered information which are not available in our databases. So we need to use some other storage, like search services we used in our research, Google search. Also, we need to increase number of knowledge bases for better understanding different topics and subject areas for this. And also, we need to add a priority of received results from terminology database when we want to receive the results from each of them, because this helps us to avoid bad data. For example, if user entered something from medicine and we checked in food or something else topic, in this case, we don't receive great results. So we need to avoid them. For this, we add threshold. And also, as I said before, terminology database needs to be divisible on small blocks, which can be combined into a new terminology database if this needed by user preference. But this feature we will implement it. For now, it's in idea state. So as for implementation, we use deep recurrent neural network with long short-term memory methods. This helps us to use in Chatbot. It's a good practice. In article we said about that. So the combination of these methods for recurrent deep neural network help us to have resistance to time gaps when user entered information by part by part. In this case, we have some time pause. Also, it's a variable range of incoming messages, because we don't say that we have only the message of few words. It can be more bigger. For example, some sentences, or maybe one, or maybe two. In this will help us to resolve this issue. Also, it's a possibility of reverse propagation, which related to recurrent neural network. About the solution that we have, it's architecture that we have. It's presented as a web service. We can use it from different devices, and it created by .NET platform with using C#, ECMAScript, JavaScript, and TypeScript. Also, as I said before, we use some APIs, external APIs like Google Search and some others, but Google Search is important in business logic. So in this case, we use, I want to present you our user experience model, which presented when user entered some text. Then we convert it into read data component, which presented by blocks of our text, which passed the semantic analysis. In this case, we send it to each of our terminology databases, which presented as a microservice. And after that, we received a result. This result will checked by our business logic module. In this case, if we found that no one have enough priority or adequate level, so in this case we use external search service, and after that we accept the result and show it to user as a result. In this case we use it, but when we tested it, maybe in almost we use our data results from terminology database. So the structure of it is too simple, but it's too great for this purpose. So for example, is the physics, and we have some sub-levels like these three databases. Each terminology database has for different alphabets the number of tables which equal to, as you see for English, is 26 from A to Z, and as a result we received a keyword set. We can create.
Sorry to
Yes,
interrupt you.
time limit.
Complete, yeah, complete.
Okay, so sorry, I will be more faster. Thanks a lot. So our testing results, we used data from Kaggle data sources, and also, as you see, we presented here some information from different of them. We checked average found times per text, average processing times, terms, correctness, and total procedure text. In this case, you will see that the correctness level is up to 85%. It's great because we use 4 terminology database. Also, we have a tests for 2, 3, and 4. Also, we create some similar applications for different methods like word-to-vec and using only simple semantic text analysis. And as you see, the performance and correctness and performance will be great when we use our method. So I think that's all. If you have questions, please ask me, and I will try to answer it.
Please,
Great.
Alex, your questions. Okay, one question for you. According to this table, how have you defined the correctness of your results for different text analysis methods? What measures have you applied to do it?
Okay, so yes, it's a great question. About correctness, we used text, and this text will combined into a simple sentence that we send to our application, and a set of keywords that we know that they are already presented as a result. So, and when we send it to our terminology databases and return the results, we compared the difference between that we had in our sentence before and after terminology database returns the results. So in this case, we combined the difference, and in this case, it's in almost situations we received 2 similar results that we had before. So, for example, we have 10 keywords before, and after terminology database will return the result, we received 7 of them. So in this case, 7 and 10, 70%.
Okay, thank you. Thank you for your presentation. Let's go on. And the next presentation is a method of detecting bot networks based on graph clustering in the recommendation system of social networks. Please, who will be the speaker?
It's me.
Mykola Yakymenko, please.
Yes. I am glad to present everyone here. Have you seen? I'm glad to present to you our research method of detecting bot networks based on graph clustering in the recommendation system of social network. Nowadays, we have plenty of recommendation systems we can meet almost everywhere when we buy something, looking for something. and in social network software. And our research is devoted to issue of information security in such recommendation systems. Main recommendation systems are having successfully attacked a social network recommendation system or news aggregator, an attacker can change the content and order of news feed items being displayed for system users. And therefore we have the relevance of our study. In existing studies, to have a detection, to detect bot networks means to detect all the bots among user profiles. Attack signs, and if such signs are found, to detect and neutralize bot profiles. The purpose of this work is to develop a method for detecting such bot networks in the recommendation systems, which could be used only after detecting signs of an attack to check only those user profiles who interacted with possible attack objects. First, we have basic models of profile injection attacks. General principle of profile injection attacks we have at figure 1, where we have set of usual users and users at whom an attack is directed, and bots attacking the system, which pretend to be usual users. Model of profile of bot attacking on the recommendation system. We have at figure 1, where here is a set of ratings to fill bot profile that are similar to real users, to pretend to be a usual user, and set of ratings for target objects which bot want to decrease or to increase. At figure 3, there are models of profile of injection attacks on recommendation systems from which we in particular we are interested in random attack, average attack, and popular attack. Next, there are some description of the method. Interesting, there are a set of indicators to determine the presence or absence of information attack on the item of the recommendation system. Capital, where there are trend, prediction of the trend, some variances for ratings and times, and number of ratings and times and recommendations, and so next.
I'm sorry to interrupt you, but 1 minute left, please. You've got 1 minute to continue your presentation, please.
Yes. And there are to solve the problem of identification, we use the coefficient of distrust, KDI, where capital E is the presence of target ratings from a set of possible targets of the attack that can take values 0 or 1. And here is a software of simulating of users and items. Some supplementary things, and there are there at the slide 8 we have example of the structure of recommendation system. Recommendation system database with created ratings in a software implementation simulation model, and some parameters of the structure of recommendation systems, and some with rating ratings. And the last slide, the results for input data for experiments with typical characteristics such as precision, recall, RMSE, root-mask intervals of bot recognition, which we can see here. Thanks for
Thank you.
attention.
Yeah, thank you very much. Colleagues, your questions? One short question. What input data have you used in your experiments to detect a bot? What data was as a simulation of bots in your experiments?
Which type of data? Data about nodes and links, vertices or nodes and links or edges, vertices are users and items, which and links are likes or something similar to.
I understand. Okay, thank you. Thank you for report, for answering.
Thank you very much.
Yeah, and the next presentation is attributed networks formation models with application in social network analysis. Please, Oksana Pichugina. You're welcome.
I'm ready, but how to share with you? I try, but I have an announcement that I cannot start screen and share while the other participant is sharing.
Yeah, I close
Okay.
it, please. You're welcome.
And now let's I will find where is. I don't know what. Sorry. And now my presentation. So my presentation is called Attributed Networks Formation Models with Application in Social Network Analysis. In the paper, networks characterized by nodes with several.
But we can't see your share screen. Can you repeat your try, please?
Share and one more time.
Yeah, please.
Try, yes. Because I see it. What about now? Do you see now it?
Yes, I can see it.
Yeah. Okay.
Okay. So in the paper, networks characterized by nodes with several attributes called attributed networks are studied. Main focus of the research is on formation models of the networks among which are social. Other related questions along with formation model, which is our focus in the network, is community detection is in networks, because this is a feature of social networks and attributed networks as well. Then reconstruction of hidden information in the network, such as missing, not attributed attributes, And of course, interpretation of results of community detection, which is here is called multi-layer community detection. A social networks is an attributed graph because both nodes and edges are accompanied by, decorated by attributes such as if nodes are people, then the attributes can be friendship, their families, school, region where they live, etc. Also, all ages are also attributed because they are also characterized by different type of relationship. Properties, normal standard properties of social networks are listed here. This is heterogeneity of node and edges, sparsity. At the same time, small average shortest path, which is the effect of small world. Then existence of communities, which is depicted as a high average clustering coefficient and high modularity. And the last one is power law degree distribution. And many researchers try to reproduce social networks, simulate all the properties, but they failed because no, for now there is no normal, very qualitative model of such networks. And one of our goals was to have some progress in this direction. Okay, so this is some mathematics within our research, because all the listed above properties can be evaluated by the following metrics. And also we use here graph theoretic approach and represent our network. So our idea was the following: to each of the attribute of nodes, we associate a network which consists of isolated clusters. Each cluster corresponds to the same value of this attributes, and then we combine each of the subnetwork forms a layer of the network, and then we combine them together and assign different weights of each of the network depending on their importance. So, and our approach. And I will demonstrate our approach on the next slides. This implementation was done in R, and we used iGraph. I used iGraph package. And first, we present three models. One of them is such that each of the layer consists of several full graphs. But real and each of the edges corresponds to the same attributes. For instance, if you are from the same school, you will have this connection. But of course, real networks have some randomness, and even in the same school, you can be not familiar with some people, other people. So we also use and present and is applied to other model where two random graphs models are used. One of them is Erdős-Reiner random graph model, and the second one Berbesche-Elbert graph model. The first one is it simulates situation when the network is formed at the same moment, and people that does not know who is more popular and interesting of people. And the second one is preferential attachment model, where it simulates situation when the group of people is formed within some period of time, and everyone can be familiarized with those who are already participated in the group. And there is a similar illustration. This is the model of each of the layer and resulting networks corresponding to model 2 with random graphs. And you see that as a result, when we combine these three and assign different weights to the networks, we have heterogeneous networks, not only with respect to nodes, but with respect to ages as well. Okay. And this is the illustration of last model. You can see that each of these components does not have any communities within the network, but we aim to form such networks that communities will be there. And this is one of main reasons why we represent it in this way as the sum of isolated networks.
Thank you. I'm sorry to interrupt you. Yeah, please complete your.
There are several slides where we evaluated which of the characteristics holds for the network, and also we conducted community detection on the networks. It is seen that first model has very low modularity, so it's not very good to simulate our goal. The second one is also modularity is about 40%. It's also low, and the last one, based on preferential attachment, it's quite good. But you see, there is not short. Average shortest path is also here is very long, so it doesn't simulate one of the listed properties. And there are two slides.
I'm so sorry.
And our conclusion is the following. Okay, that the third model is better simulated social networks, and so this is our contribution. Thank you for your attention.
Thank you very much. I'm so sorry to interrupt you, but we've got time limit.
I know that the session will end.
Yeah, yes. Thank you. Yeah, thank you very much. And if there are no speakers of the second presentation, we will watch the video.